Good morning, folks. This is the second lecture of week 3, and we're going to start the shell elements today. But before I do that, I want to discuss something else that we have been doing and needs to be taken care of. The items on the agenda are shown here, but the first thing that I want to talk about is this business of creating patches and points, which can be done to be used by the measure in the solid situation. And then we come through these. We go through these later on. One comment that has come up with by student is, are all finite element packages the same? And the answer is no. Essentially, finite element packages are divided to two broad categories. One of them is called the implicit solvers, and the other one, the explicit solvers. Implicit solvers are the most commonly used, and the most commonly used because it meets the needs of maybe 95% of the industrial applications and even academic usage. But explicit solvers are specialized problems, or to handle specialized problems which are of the short duration and extreme nonlinearities and extreme contacts, such as what you see in, for example, car crashes or stuff like that. Now, obviously, the CATIA program that we're using here has an implicit solver, and it's a very rudimentary explicit solver. Sorry, not explicit, implicit solver, and it's a fairly basic one. But we have to learn we have to learn how to crawl before we walk. Okay? All right. The first item that I want to talk about is if you have a structure solid, such as this. For example, left end is clamped just to make it easier. And what you want to do is define pressure not on the entire top face, but maybe on a patch of it. How do you handle that? Or if I want to put a force at a specific location in my model, how can it be done? Okay, because generally in a situation, if you model it like this, unless you do some additional work, which is not hard, by the way, some additional work, when you select pressure and this top face, is going to put it everywhere. Or when you select a concentrated force and that top face, it's going to divide it into, uh, let's hypothetically say we have 100 nodes on that face. Let's divide this force into 100, and on each one of those nodes on this top face places a concentrated force. We don't want that. So one way to fix the issue of the pressure is go to your model, put a small feature here, maybe a pad or a pocket. So basically you're changing your geometry. And as long as the height of this is not very much, okay, maybe it can represent what you want to do, but we don't want to do that. We don't want to change the solid geometry by making it by giving it a feature that is unnecessary. Okay, so the alternative is you want to put a surface on this face somehow. For example, you go up there, draw a circle, and fill, Fill, use the fill option in the wireframe and surface design, for example, to put a surface in there, and then sew that surface to this object. And when you sew it, you may have to make sure that this arrow is flipping towards the solid object, and uncheck the simplified geometry. That's all that's fitted here. Okay, that's one way. So I'm going to do that problem for you that way. And then when it comes to, if you have a point on this face and you want to put, for example, a force on this point, what you need to do is when you mesh this, or if it's already meshed, double click on it, on the top, there is a tab. One tab is called quality. I'm sorry, not quality. This is a mistake. It should be on local. This is a mistake. That should be on the local, not quality. On the local, and you select the imposed point. Okay, just to make sure that this is corrected right now. Local. All right, go back. Local and impulse point, add. And when you do that, this box pops up. Make sure you select that point, and then you can see that when you look at your mesh, there's a tiny dot here, green dot there, which means that you can actually put a force at that location because that location is guaranteed to be a node. You can see that if you zoom in, you can see that it's common between several elements. All right. So I want to solve this problem for you, and then we come back and do the rest of the presentation. Well, I'll start with the part file. By the way, they can be done at the same time, a patch and a point, but I'm not going to do that. I'll do that separately for you. So on that horizontal plane, I will sketch something like that. Let's ignore, completely ignoring any dimensions here. Now I need to pad that, so I have to be in the part design. You pad it. Okay, that's fine. And you apply material to it. So apply material to that part. Let's say made of aluminum. That's really not the issue here. And now we're going to go to analysis and simulation, generative structure analysis. Oh, cancel. I forgot to put the patch in there. Okay. So let's go back to, because on that face, I will sketch. I completely forgot what I wanted to do. So on that, I'm going to draw a circle. Maybe I want to put maybe I'll make it an ellipse. How about that? I'll make it an ellipse. Okay. Exit. And now I want a surface on that sketch. Okay. So as soon as there's surface, you're going to have to be in wireframe and surface design, or the more sophisticated version of it, generative shape design. But here, you go to mechanical design, wireframe, and surface design. Look for the icon which allows you to make surfaces. So this is the toolbar which allows you to make surfaces. This particular one says fill, Fill. You click on it. You select that closed sketch. Okay, you selected it, and you say okay. There we are. So notice that I do have a surface there. I can hide it right there, or I can show it right there. And now we're going to go to analysis and simulation, generative structure analysis. Okay. And it doesn't matter what we do here, because we obviously I want to show you how to put a pressure here, but cannot go to frequency because that does not have any load. All right, so let's see. Notice that we have this fellow there. The only thing that I forgot to do was to sew it. No problem. I forgot to sew it for you. So let me minimize that. Go back to part design. This is not part design. This is the wireframe and surface design. Switch to part design. These are things that I forgot to do. Please, you notice that. Here's what I did. I made the part. I sketched on the top. I put a surface on it by FILL, and now I have to sew it. To sew it, you have to go back to the part design. I'm in part design. Okay. So there we are. Expand this, and there is an icon which says sew surface right there. You see that? Sew surface. You click on it. This is the toolbar that I was talking about. You select that patch, either from the tree or from the screen, doesn't matter. There. Make sure the arrow points down. Put the cursor on the arrow. Flip it down. Make sure this geometry is unchecked. Now, let me show you what happened if the geometry is not, if this simplified geometry is not checked. Let me not check this thing for a second. Okay. I have to check it, but I want to show you what happens if you don't. You say, okay, not check. Go back to the analysis. Okay. And show the mesh. There. You see that? This feature is not taken. Even if I made this thing smaller so that you can see it better, maybe. Maybe it's so big that we can't see it. Right click. Where is that? Activate. You see, the surface is not, is that patch is not respected by this element. So let's go back to there. We go to our, where is that? Is this the part? No, the other one. Double click on the saw, check, uncheck this. We say okay. Now go to your analysis and update the mesh or update and activate. Deactivate. You see this? Right there. I can see this. You see that? Right there. You see the ellipse? It's sitting right here. Good. So in fact, if you say show me the part, it's right there. See this? Good. So let me hide the part, deactivate the mesh. Okay. Now, for example, I'm going to go and say, okay, so I don't even have to see the surface. I can hide it if I want. Actually, yeah, even if I hide the sketch, I will be able to see the feature right there. You see this? Good. So clamp, for example, the side and put a pressure on that feature. You see that? It's only on that. And then you can run it. That's really not the main thing here. So basically, I created my part. The place that I wanted to sew something, I sketched it, I filled it, F-I-L-L. I sewed it, make sure arrow is down, that box is unchecked, and then go to your analysis and mesh it. You see that it will respect that patch. And if you here apply the load here, obviously it's going to go down. There we are. And there, there. Okay. It pushed on that and it pushed it down. Very good. So now we're going to go and repeat the same thing, except that I want a point there. And I want that point to place a force on that point. Okay. So let me get rid of this. I'm going to start this thing over. All right. So let's start with the part file. On that plane, I will sketch a rectangle, exit, add it. Okay. Now I want to point on this face. So here's a point on a surface, on that surface. Let's say this this blue dot. Very good. So we have a point here. You can see that right there. There's a point. You can see it from the tree there. All right. Now apply material to this. Excellent. Now we're going to go to analysis and simulation, generative structure analysis. Now the point is this point is there, but even if you clamp this in and you put a force on that point, CATIA will not see it, or it may not simply run, because this is a geometric entity right now. Okay, you have to do more to it. So notice that it is already meshed. Okay, it is already meshed. If you double click on this, if you double click on that, let me change the rendering here. If you double click on this, this pops up. and there is a tab local, and you want to say impose point, and then you say add. This pops up. Either you select it from the screen or from the tree, either way. Notice that if you looked at it, there's a little green dot here, and then we say okay, and then okay. And now if you say show me the mesh, believe me, this point is going to be one of the corner points of the elements. So if you say right click mesh visualization, you see this right there, that's guaranteed. And because of that, when you put a point here, it's actually, sorry, when you put a force here, it's actually transferred to the information around it. Without that, this point is going to be somewhere in the middle, and you put a point there, you put a load there, it doesn't know what to do. Okay, deactivate this. All right. And then you're going to, for example, clamp that end and apply a force, concentrate the force on that point. It will let you do that. Although it says point here, but it will take it into account. Let's say -1 pound for sake of illustration, and run it. These numbers mean nothing. I'm just showing the process. And then, of course, it's going to get pushed down. You can see that. Yeah. If we had not done that, you can see that that force that we put in there is actually placed on that. Okay. I put it in the, oh, what, I might have had another component there. Oh yeah, 1 and 1. Okay, so that make this thing 0. Yeah. Because I just wanted 0 and minus whatever, -1, and now it's going to go down. If you run it, because there were two components of the force that went down and sideways, but now it's going to go down. Here's that. There, as we expect. Okay, so what I've done here is shown you this situation. That was the creating of the patch and sewing. Make sure that these are respected. This box I showed you, if you don't check it, it's not going to happen. And for this one, you had to select the local tab and then add impose point, select the point, and then you can put stuff on it. Okay, now we're going to go to our stuff with shell element. Okay. So far we have discussed solid elements. What I refer to as solid elements, these pyramid-like elements, which also refer to as tetrahedron. And then we talked about beam elements. We did several problems, about a week on beam elements, and now we're going to do about a week worth of work on what is called shell element. If you have structures which are relatively thin, this is not quite the condition that you need, but you can always think about it in those terms. Thin in one direction when compared to the other two directions, such as a pop can, car bodies, like the trunk, the roof, etc., the hood. For example, a bathtub that has been thermoformed or whatever. These are thin in the thickness direction compared to the other two dimensions. Actually, as I said, that is not a good way of describing it, but that's the first way that it comes to my mind. Now, you don't model the three-dimensional object, you model the surface of it, okay? And these elements, shell elements, which looks like triangles, or the more sophisticated version of it, which is parabolic, linear parabolic, they go on surfaces. For example, if the surface is flat, it doesn't matter whether you put this or that, it represents the geometry well. Of course, these are more accurate, but it represents geometry well. But if the surface is curved and you put this thing on that curved surface, obviously the surface is going to deviate from the element because this is just a plane. But if you have a parabolic version of it, it approximates that curvature of the surface better. Now, that one of these three noded one for simplicity is drawn here in space. Each node has three nodes. Linear one has three nodes. Each node, just like beam, has 6 degrees of freedom, 3 translations, and 3 rotations that are represented here. So a single linear element has already 18 unknowns in it, okay? In degrees of freedom. If you look at the beam element, a single beam element, linear, has 12 unknowns associated with it, 12 degrees of freedom associated with it. If you take a solid element, linear one, it has 4 nodes. Each node has 3 translations. Rotations don't play a role there. So 3 translations. So each linear element has 4 times 3, 12 degrees of freedom or 3 translations. Okay. Now, because shell elements go on surfaces, I want to quickly go and remind you on how you did surfaces in CATIA. So let's go here. I already have done one for the problem when I did this for you. Remember, I created a patch here by drawing something and FILL, filling it and then sewing it. Sewing is not part of the surfacing, but it's in the part design. If you have a surface, you want to sew it, that's fine. So let's go ahead and do a bunch of problems here. So some quick reminder, review of what you did in wireframe and surface design. Now, let me get through this. And let me do the problem that we have. Now, let's see. Let me go ahead and make a box. We start with part design. Okay. Actually, instead of making a box, I will do maybe a cylinder. Yeah. So on that plane, we're gonna sketch. we okay, I'll do something like this. The first circle, maybe something like that, and then close this up. From here to here, and from here to here. Exit, add it. Let me make it even higher. Okay, something like this. Now we have a solid object here. Although there are faces here, there are no literally surfaces, okay? In the conventional sense of CATIA. So as soon as you say, I want to get the surface, these 3 surfaces, I want to get these 3 surfaces for some reason. So as soon as you say surfaces, you either go to mechanical design, wireframe and surface design, or you go to shape, generative shape design. In fact, if you look at the icon here, that looks pretty much the same as the icon that you have in wireframe and surface design, except that the colors look different. There is a little bit extra thing there. So let me go remind you one more time. Mechanical design, wireframe and surface design. Just look at the icon. Very similar, color different. And this is the baby version of that workbench. So you click on it. You already know that because that's where you have done join and things like that. Now, there is an icon which says extract. You see this? Extract. This is the extract toolbar, or actually, let me see what actually the whole name is. I'm not sure, but anyway, there's the extract icon. Extract, because this does something else. Extracting the boundary, probably. Yeah. So this is extract. Extract. Click on it. it says, okay, what do you want to extract? Well, for example, I want to extract this, turns green, and this one. Now, if it doesn't take it, what you can do, either pre-select, let me show you. If you select these three, this, control that, and then click on extract, it does both of them. Alternatively, if you click on that, you extracted this, and then you want to extract the other one. You click on this little bag here, it says, okay, now I'm going to select that. So these two will be selected. As a matter of fact, let me do all three of them and say, okay. So I can hide my part. My part is that gray thingy. And those surfaces are there. These are surfaces. That part is there. You didn't delete it. You cannot delete it. Because if you delete it, you extracted something off that part. It's going to get rid of these two. Now, if we change our mind, for example, we don't want this thing to be there. I can go there and, what is that? Either deactivate it or delete it or deactivate or delete it. If I deactivate it, it's the same as deleting, except that it's going to be there. If you change your mind, you can use it later. I'm going to delete it. Okay, good. Now, these two, they're two surfaces and they don't talk to each other. It means that if I mesh this thing with shell elements, and I will later on, there's going to be duplicate nodes, the one element from the top and the element from the bottom at that seam. But if you join them, okay, if you join them this and that, then when you mesh it, it respects the fact that this is common between the two things that you extract. All right, fine. Now I'm going to create the same thing a different way for you. Okay, so I'm going to close that. I don't need it. Let me start with another part file. Okay. Because I'm going to create the surface without actually making a solid object, here's what I'm going to do. I can be in wireframe and surface design. I am already there. I don't have to be in part design because I'm not going to make a three-dimensional object. So on that vertical plane, I will sketch. Where's that sketch? Right there. An L like this, inverted L like that. Exit. And then look at the way you make surfaces. See that? You make surfaces. One of them was fill, F-I-L-L, that I already used. And there is another one which says revolve. You select revolve. It says, where is the profile? There's the profile. It says about what? About what? Well, I can say about the Z-axis. By how much? By, I don't know, this says 180 degree by default. You go to 45. And there we are. If you go this route, you don't have to join these two because of the way you did it, it's essentially a single piece. Notice that when I select it, the whole thing is selected. In the other one, when I selected, it was extract one, it's just the top piece. Extract two, just the curve piece. Okay, and I deleted extract three, of course. But here, that's why I joined it. So when I selected join, the whole thing is selected. But here is all one thing. You mesh this thing, there's going to be the same node from the elements on the top and the bottom. Okay. And this FILL I've already done, so I'm not going to bother. And these are some primitives that you can make: a cylinder, a sphere, but that's fairly limited. And this is extrude, of course. You know what extrude means, okay? So in the next example, let me do another one for you. So for example, on that vertical plane, I will sketch. Let's say, I don't know, maybe something like that. Exit. If you extrude, it's going to give you a flat surface in that direction. You can extrude along other directions also, and but I'm not going to do that right now. Okay, now the alternative would have been draw one sketch, one line, and another line, okay? And then extrude that and extrude the other one to get a shape like that. The only thing is that because of the way you have done it, because you have done two extrude, these are not, these are independent of each other, and you may want to join it depending on what you want to do. Here, it's already joined. Look, when I selected, the whole thing is selected. If I had drawn a line, extruded it, another vertical line, extruded it, then you get two extrudes. So when you select one, both of them are obviously are not. Okay. All right. So let me get rid of this, and we're going to do our first shell probe. So here's the situation. This is a thin structure. The dimensions are given, some dimensions here, and it says the thickness is 0.1. So immediately you have to realize that if this problem is to be solved with finite elements, you will have to, I'm saying you will have to solve it as with shell elements. Okay? If you just do solid elements because you don't know shells or you didn't realize that, I'm sorry, but there's going to be substantial number of point deduction because I don't, you don't know it. Okay, so the dimensions are given. These ends, this bottom end and that end is clamped, and you apply a pressure here. The first thing is, how many planes of symmetry do you see here? Well, I hope you realize that all you need to do is to create 1/4 of that. 1/4 of this model. Okay, 1/4. So the choice is yours. Either make the whole thing and then start cutting it with a plane so that you get 1/4 of it, or you make 1/4 of it. And once again, the choice is yours. Either you draw an L like that and say extrude it, or draw a line, extrude it, draw another line, extrude it. If you go that route, you better join these things. Or you can make a box, either this size or that size, extract the faces, the two faces that you want, such as the top and the side face, and then if you go that route, you have to join, because extracting the top and extracting the side will give you two different surfaces, and they don't talk to each other unless you join them when it comes to finite element calculation. So let me do the following. Let me go ahead and on purpose, it's a bad idea, but on purpose, I'm going to make a box. I'm going to extract the faces and get this and join them. Okay, the dimensions, let's see now, 2, height of 0.5 by 1. So it's going to be 2 by 0.5 by 1. 1/4. You have a whole week to work on these things and try different things as you see fit. So part, say okay. Because I said I'm going to make a box, I'm going to go to part design. On that vertical face, we'll sketch a box that is 1/4 of that size. Let's see, where is it? Dimension. This one, for example, it was 2. This is 0.5. 5. Exit. And pad by 1. So actually, this geometry that you see here, is this 1 inch, 2 inches long, 0.5 high. Good. And of course, you can apply material here or later. Let me apply material here. I am not sure what this thing said. Brass. Okay, fine. Brass. I say okay. And okay. Now, I need to extract this face and that face. So to get that geometry with surfaces only, you have to extract just these two faces. So what do you do to extract? You don't stay in part design because you're talking about surfaces. You're going to go to mechanical design, wireframe and surface design, look for this toolbar, which I'm pretty sure it says extract, and looks for this particular one which says extract. And you can either pre-select these, or you select this, and then click on that, and select this, and say OK. If you had pre-selected them, it would have done both for you. And notice that I can hide that. This is going to be in hiding. You can see that it's back there. It's right there. So what you see there is actually this folded sheet metal. All right. Now, let's apply material to this thing. Oh, I already did that. Sorry. Cancel. Now you have to join these things. Remember, to join these, you have to be in the wireframe and surface design, and you're already there. That's how I created this, by extracting these surfaces and join this surface and that surface. And we say, OK, let's save this thing. File, save management, save as. I have a folder here. I'll call this thing a folded sheet. So this stuff is going to go in there. And OK. Now, when we are done, we're going to go to analysis and simulation, generative structural analysis. This top one is for fancy stuff in meshing or fancy meshes. Generative structural analysis meets our requirements. So at some point, I will be using that and responsible for some of the features of it. But right now, generative structural analysis. So what CATIA does, it says, OK, first of all, static analysis. When it puts an element here, you say, wait a minute, I don't have a solid object. Yes, you do. It's in hiding. Yes, you do. It's hiding. So if you go this route because you created a solid object, it meshes that. But I don't need it. Make sure you delete this. Notice that it created the solid object, a solid element, tetrahedral element. Delete that. And delete the 3D property, because otherwise, if you don't, it's going to come back and say, hey, you have a 3D property, but you don't have the element. So essentially, I start from fresh. I did not delete the part. The part is there. The part was meshed because CATIA sensed that there is a 3D object there, and it meshed it and created a 3D property. But I don't need it, so I delete it. I have to do the rest myself. Okay, now I have to mesh this. So look in the model manager. Remember where you got to mesh things yourself, for example, for beam. This is solid. If you change your mind for some reason, you wanted that solid, you can mesh it yourself, but I don't want to. And there is the octi-triangle mesher, the fancy way or CATIA way of saying mesh shell element. You click on it. Remember, you joined it. Because you joined it, when you select, both surfaces are selected at the same time. If you are not joined it, this surface, you can mesh it, and that surface, you have to do it again, and they don't talk to each other along the seam. But because we meshed it, because we joined it, both are selected. Now, what it does, it puts something that roughly is the size that you want. If I don't want that, it's too big, I can change it here. Point, I don't know, maybe point 2. Linear and parabolic. And remember, there is this tab there. In the event that you want to include certain point, you go to local at impose point. We already did that at the beginning of the year, but I did it for solid. It applies here too. And then we say, okay, did I change that? Maybe it was 0.2. I'll make it 0.05. Linear variety, parabolic variety right there. Would you like to see it? The cursor there the usual way. Right click, mesh visualization. And there we are. You can see that. Don't let it bother you that it doesn't put this thing on the surface. It depends. If you had a single surface here, it would put this thing there. And if there, but because we joined it and it looks like that, because it looks like this folded, it's going to put it probably at the centroid of something. Now, if it's too big, double click on that and make it 0.1. Okay, activate. There, course mesh. That's okay. We leave it like this. And we deactivate. All right. Now, the rest of it is just like before. The bottom of this edge is clamped. So I click on that and you select this, and this is all clamped. The bottom is all clamped. Very good. Now, we took 1/4 of the model. In other words, this edge and that edge, or you want, and that edge, these three of them, these three lie in planes of symmetry. For example, this edge and that edge lie, according to my axis system, these two edges, this one and that one, lie in the YZ plane. And for symmetry, you have to use the same stuff that I did in beams. That edge lie in the XZ plane. For symmetry, you'll have to do exactly the same thing. So what do I mean? You click on the user define, make sure nothing is checked so that you start fresh. This edge and that edge lie in the YZ plane. YZ plane. As soon as you say YZ, no X. No translation in X. Rotation is exactly the opposite. So anything that was unchecked here is going to get checked. And obviously anything that's checked is going to stay unchecked. So that's okay. If it helps you, you can go ahead and name these things. So you can say this was YZ plane. Don't say user defined 1, user defined 2, etc. But that's up to you. So I'll do the next one like that. Another user defined. Uncheck all of these so that I don't make a mistake. I select that box, and that's what I mean. You can call this thing in the XZ plane, XZ symmetry. The other one I should have called YZ symmetry, but these are all bookkeeping important, but bookkeeping, but okay. If it's in an XY plane, not XY, sorry, XZ, not XY, XZ. If it's in XZ, no displacement in Y. And rotations exactly the opposite. You cannot leave these things alone. Very good. Pressure on that. What's the value here? 100 psi. You put 25 psi. 100 divided by 4, 50 psi. Bad idea. When you apply pressure, you don't divide the pressure to 4 because you're taking one. If this was a load, if I was applying a load of 1,000 pound here, then on that piece you get 1/4 of it. So it's going to be 250. But if it's pressure stays as it is. 100. You say okay. Incidentally, if this is to be upward, then make it minus 100. In other words, if you apply the pressure from the bottom so it pushes out, you put a minus on. Now, the only thing that let me try to run it and show you that you will get an error message. You better know what that error message says. Okay, so let me run it. It looks like I'm done. I'm going to run it. It comes back, hey, wait a minute. Acquisition of field model failed. Could not find property. Check your model. That's because if you look at the property here, nothing is done. It doesn't even know what material it is. Because for 3D object, it did it automatically for you. For beams and shells, you have to do it yourself. So you go here, not 1D property, not 3D property, 2D property. You click on it, and it says, okay, what is your support? Well, because I joined it, I select the whole thing, pick the material, brass, and put the default thickness. Now, this is not my thickness. My thickness is 0.1. See that? 0.1 inch. So now we're going to say you change this number, but it doesn't display it through, unfortunately. But this 0.1 applies to both surfaces because I joined them. If I had not joined these things, this would take a proper 2D property, this would take a 2D property, etc. Now, let's save our analysis and then run. So we're going to go to File, Save Management. Here is the analysis. Don't worry about these temporary thingies. Okay. Save as, that folder, folded sheet. Okay, very good. And this time we're going to run it, and we're not going to get that error message. Good. Finished. So how does it look like? Well, here's the deformation. You can animate it. That's the way it should be, right? That top is subjected to a pressure. This thing goes down, obviously. Displacement. There's a displacement. If you want it in the form of color, double click on the contour, average ISO, and change the rendering to material shape. There we are. Obviously, biggest displacement is going to be at the center line here. You can see that. And the value of it is 0.004, 4,000, basically, 4,000ths of an inch. Okay, good. On mesa stress, yes, we can. In the case of beam, you could not plot, but in the case of shell, you can, right there. And there we are. So the biggest stresses are at this fold, that makes sense. And over here, because that's not the biggest stress, but anyway, big stress there because it bends the most, okay? Now, in the event that you want to see your elements also superimposed, now, first of all, anything that you don't like, you can hide. These restraints, if I don't want to see them, I just hide them. Either from here or from the sea. The load, if you want to see it, you can hide it. The property, if you don't want to see it, you can hide it. This element, this representative element, you don't want it, you can hide it. There we are. Okay. But if you also want to see your elements here for some reason, you go to the rendering icon, the very last one, question mark. Notice that because edges and points are checked already, it shows you the elements also. And then you can animate stuff like that. Now remember, we have a whole week to spend on, maybe a week and a half or a week to spend on shells. So this is just the very first example that I did. Incidentally, let me quickly show you what if I did not join this. So I go here quickly. Let me get rid of that. So start part file. What I meant was, what if I did not use a solid object to do that? So on that plane, I will draw an L, inverted L, like that. Exit. And the method to make that surface is extrude. So you can do it like this. There is no solid that's in it. So when you go and mesh this thing, you have to mesh it yourself. The solid is not meshed. You don't have to go through the business of deleting the 3D property and 3D element and then mesh it yourself. But you will, yeah, you will mesh it yourself. Okay, this is just the beginning. We're going to do more of these later. Notice that I'm not joining it on purpose. Okay, so let me put material on it. For example, I don't know, whatever brass it was. All right, so now we're going to go to analysis and simulation, generative structure analysis. Change the rendering here. Notice that nothing was meshed because there is no solid element hiding. Okay, there's no solid element, so I have to do that myself. Now, when I click on this and I select that and I say OK and say show me the mesh, look, right-click mesh visualization, it just shows me. It shows me both pieces because I extruded it. It's already joined. Okay. But if I had created this part a different way, the rest of the problem is the same. Okay, there's no problem. But If I had done it like this, let me go and do another one. Okay, let's start with the part file. If I go in there and draw on that plane, sketch something, maybe a line like that, exit, and another one like so. Actually, let me go. Yeah, let me go here and bring this thing down right there. Okay, exit. On this plane, another sketch, and my sketch goes like that. Another line, like so. Actually, let me make sure that this is on that line. This control that you make it coincident. Very good. Exit. Let me apply material to this. It's not necessary because all I want to do is mesh. And now I'm going to extrude this. I'll make it 10 or maybe 5. And then I extrude this 5. And I'm not going to join them. So now when I go to generative structure analysis and I mesh that fellow and I say, show it to me. There. I don't see the other one. So deactivate that. And then again, another one down here. Fine. Show it to me. It'll show both. But look, if you put the cursor at this element from the bottom, you get a bunch of node numbers, 213, 214. And on this side, you get 11, 12, etc. That's why they don't talk to each other. When you try to run, it says, hey, I don't see you, and it's going to bomb it. So that's pretty much it, folks.